There you go. So well, hopefully you did. F of x is 3x minus a2. So on the other side, wherever you have that x, so instead of putting a 3x minus a2, I am telling you that we want our x to be substituted in as a value of 2. Then whatever that evaluates to be, so that's going to be a 6 minus a 2. F of 2 equals 4. What that then simply means, I had to do this on the homework last night. We did it in notes yesterday. If we were to graph this, it's really just a different way of writing a point. That would be the point 2 comma 4. So I'm not asking you to do that necessarily here, but just understand how these guys are related. Same with letter B. Instead of 3x minus a2, you're going to plug in 0 into the spot for x. You get 0 minus a2. So when x is a 0, we get a functional value or a y coordinate of -2. And then the last one, same thing. Instead of 3 times x minus a2, we're going to replace the x position with the -2 that you're told to do with right here. So we get -6 minus a 2. So when x is a -2, we should get a y value of -8. All right. Okay. So we're going to do that today, but it's going to be a little bit different. But that's definitely something we're going to do today. All right. Number 2, I want you to graph these two linear equations, what we kind of wrapped up the period with yesterday. So if I look at this one here, these are both nicely in slope-intercept form. So I should be able to look at this first one. I'll do this one over here. Y equals a -x minus a 4. If I ask you what your slope is, the slope is always the number in front of x. So in this case, it's a -1. If I ask you what your y-intercept is, it has to be the -4. So in terms of graphing it, that just means we go to the -4 on the y-axis. Careful with the -1 slope. There's a couple different ways we could approach this, but just recall when you would have done these in the past, if this isn't a fraction, the slope, you were probably told to write it as a fraction just for the sake of counting. So this would really just be a -1 over a 1. And then the idea is that this is my change in y. So the -1 means I go down 1. The +1 means I go right 1. So I'm going to go down 1, right 1, down 1, right 1. And then hopefully we also understood, well, that means I could go up 1 and left 1, right? Up 1, left 1, up 1, left 1 to get this line. All right, so that is the line y equals a -x minus a 4. If we do the other one, y equals 2x minus a 1, or 2x plus a 1, the slope in this one would be a 2, which for the sake of graphing, you may want to write as a fraction, 2 over 1. We know our y-intercept is a +1. We go to our y-axis, start at the y value of 1. And then a slope of 2 over 1 just means we're going to go up 2. We're going to go right 1. So up 2, right 1. Up 2, right 1. Up 2, right 1. Draw in that line. And then that should be 2x plus a 1. What we do today, it's going to be a little harder. It's going to be weird. But it's nothing more than those 5 problems. Finding functional values and then graphing lines. We're going to tweak some things a little bit, but it really boils down to being able to do those couple of things. All right. All right. So a piecewise function. Think about the word piece. It's in pieces. That's the reason it's called a piecewise function. You're going to get individual pieces of a function. So if we want to have a function to behave differently depending on the x values, we need what is called a piecewise function. A piecewise function is just a function that uses more than one equation to describe its behavior. When we graph piecewise functions, we are really graphing different pieces of different lines. And they're not necessarily always lines, but different pieces of different functions. But what we're going to start with is lines. So what this now means, if we go and look at this, this is what is called a piecewise function. So if we look at this thing here, it's called a piecewise function because what you have are 2 different equations. One equation is this guy, and then the other equation is this guy. So we really have 2 different equations. You don't necessarily need to write it, but one equation is nothing more than 2x minus 5. The other equation is y equals 1/3 x plus a 1. But if we want to write it using just one function notation, then we put this bracket around it here, and we say that f equals 2x minus 5, but it also equals 1/3 x plus a 1. So hopefully we all agree that's two different equations. So which one do we use? All right, that would be the question. So if I now ask you, what is f of 1, like we did at the top of the beginning of the notes here, which one do we plug it into? Well, look at what we were given here and then here. So let me do these in colors so that we understand what I'm getting at. The first one, the yellow one, we're only going to use that one if our x's are less than 2. So if we look at letter A, is the x value that I'm asking you to evaluate it at less than 2? Is 1 less than 2? Yeah. So because 1 is less than 2, that's what this one is giving us. We're going to take the 1, we're going to plug it into that first part of the function. So we're going to write this now as, instead of, let me use black here, instead of 2x minus a 5, because that's the function we want to use, just like we did on the top. Wherever we have an x, we're going to plug in the 1. So f of 1 is equal to 2 minus a 5. So f of 1 would be a negative 3. Okay. If we go to letter B, look at your x coordinate in letter B. So here's 2, right? Now look at our two intervals up here, all right? And figure out which interval does the x value of 2 fit in. So the question would be, is the value of 2, is that less than 2? No. Is 2 greater than or equal to 2? Yes. So this guy is defined by this interval, which means for this one, we're going to use the 1/3 x plus a 1 to figure out what f of 2 is going to equal. So we're going to take the x value, or the x position, and instead of doing a 1/3 x plus a 1, we're going to plug in a 2 where that x is at. So for this one, f of 2 is equal to 1/3 times 2 is just 2/3 plus a 1. I mean, I wouldn't necessarily mark it off if you just want to write 1 2/3, but that's also 5/3. It's not necessarily wrong if you give me 2 or 1.666. If you want to give me the decimal, it doesn't specify. So any of these answers would be okay. 1.6 repeating would also be fine. All right. So real quick, do number C, or letter C. See if you understand, what did I do in A? What did I do in B? Figure out what f of 3 would equal. All right, Cam, what you got, Cam? Yeah, walk me through it. What did you do first, or how did you get it started? Okay. Good. So the x, all right. Yeah, so we said the x value of 3 is what we're working with. If we look at this interval here, 3 is not less than 2, but 3 is greater than or equal to 2. So that's why he said he chose the second function, because 3, if I plug a 3 right here, this is greater than or equal to 2. So then you plug that in. So 1/3, and then our x is a 3, and then plus a 1. Right. Good. So 3 over 3 is a 1. Add that to the extra 1 in the back. So our functional value at 3 should have been 2. All right. So that's our first one. Second one, pretty similar. Just some different function now, different interval. Careful with the negatives. Think of a number line now. So let me actually draw a number line in here. I know it seems maybe childish, but people get negatives mixed up all the time. Look at the intervals that you're given to work with. So I'm going to use x squared whenever I have an x value that is less than a -4. So let's do it this way so we hopefully understand. If x is less than a -4, that's all of these values, because these are the values that are less than a -4. If x is greater than or equal to a -4, so equal to and then anything to the greater than side, we're going to use the second part of that function. So if we go to letter A, -6, if we look at our number line here, isn't -6 less than a -4? So we'd have to use this part of the function. So you're going to plug in, instead of x squared, because that's the function we need to use, you're going to let your x become a -6. So f of -6 is 36. All right. Letter B, we want x to be a -4. So now we have to look at the first interval, look at the second interval, and identify if x is a -4, which it satisfies which inequality, the first one or the second one. And whichever one it satisfies, that's the one we plug into. Right, and it satisfies the second inequality there. So since -4 satisfies this inequality, we're plugging it into the second function. Now, be careful with this one. This means I want a negative of x, so I want a negative of whatever x is, and then I'm going to add 2. Our x is a -4, so it's kind of like the quadratic formula with the opposite of b. So we want a -4, so that should be a +4 plus 2 should get a 6. All right. Okay, the last one, f of -2. Again, here's our x value. -2 is the x value. We want to look at our two parts here and here and identify where does -2 fit. Is -2 less than a -4, or is x a -2 greater than or equal to -4? That's why we kind of want this number line. Isn't a -2 on the greater than side of a -4? Yeah, so this is the greater than side. So we would again want a negative of whatever x is, and then plus the additional 2. So f of -2 is +4. All right. So that's how we can evaluate those. We also talked about graphing. So now let's say I ask you to graph these. So here's how we're going to do this. The first one, I'm going to have you actually write these two different equations out. So one equation is nothing more than y equals 2x minus a1. We're going to kind of graph this one. So we would hopefully know, we reviewed this at the beginning, we did these yesterday. Our y-intercept's a -1, so put your dot at a -1. Our slope is 2 over 1. So from this point, we're going to go up 1, 2, right 1, up 2, right 1. And what I want you to do, for the sake of this problem, put in as many dots as you can. So keep going up 2, right 1, up 2, right 1 until you get off of the graph. And then I also want you to work backwards. Go down to left 1, down to left 1. But don't connect those. Do not connect those dots yet. All right, that would be our line 2x minus a1. Then write the second equation, -x plus a 3. Hopefully we can graph that pretty quickly. This is our y-intercept, the 3. So go to the y-axis, put a point on 3. Our slope is the -1. So again, that just means I have a -1 over 1. So from this red dot at 3, I'm going to go down 1, right 1, down 1, right 1. And again, put a whole bunch of these. Put all of them that you can. So that means I could also go up 1, right 3, or up 1, left 3. But do not connect those yet. The reason we now don't want to connect them is we don't want these entire lines. So think about this line right here. So if we talk about this one, go back to our function. We only want that line for x values that are less than or equal to 1. So go to your x-axis. So here is our x-axis here. Find the x value of 1 on the x-axis. So that's obviously right here. Oops, let me do this in black. We only want this line for all x values that are less than or equal to a 1. So I want this one, and I want all of these guys. So I'm going to connect all of these. But notice how this x value is not less than or equal to 1. This is not less than a 1. So what I would then do, long term, we don't want these to show up at all because our graph doesn't exist over there. If we go to the next one, so now if I go to this negative x plus 3, look at the interval that that one is good for. So if I go to this one, isn't that only good for when x is greater than 1? So for this one, we only want this graph for when x is greater than 1. So again, go to the 1 right here. This point has an x value greater than 1. So does this one, and this one, and this one, and this one, and this one. We then want to connect all of these guys because these are all the x values that are greater than 1. All the dots over here, the x values on these are not greater than a 1, so we really don't want those there. All right, so we have this line for all x values that are less than or equal to 1, anywhere to the left. Let me actually kind of do it this way. Let me think about where x is a 1 here. If I draw a line in black right through the x value of 1, don't I have the black line to the left of it, like this is telling me I'm supposed to? And then I have the red line to the right of it, like this one is telling me I'm supposed to. Okay? Now, there's one extra little thing here. Let's see if you remember this guy. So last year, you would have talked about open dots and closed dots. Sometimes you had a closed dot. Sometimes you needed to leave your dot open. So when we do this, look at this one right here. See the equal to sign in the 2x minus a 1? We want this dot to be closed. So close that one. But take a close look at this guy. Does this one have an equal to underneath it? What that means is we don't want that first dot at 1 to be here to be open. So what I want to do, hopefully I can just erase that one dot, is we want to go there and we want to make this an open dot on that graph. Do you guys remember the vertical line test to determine if a function is a graph is a function or not? It has to pass the vertical line test. If we pass the vertical line test, it can't touch the graph more than one time. If this was a solid dot, wouldn't it touch the graph on the red dot and the black dot at the same time? It would fail the vertical line test. So by now leaving this open, we don't actually touch that graph. We're only touching the black one, and the red one is left open. All right. So that's what this graph would look like. That's not easy. Okay. I review this with my calc kids for the first 2 days of the school year because they do this a lot. And it's something that you have to recall and remember. There's a lot going on with these. Okay. So let's see if now you can understand what we're doing in this next one. So same idea. Let me see something here. What's that? You might. Yeah, you might. Yep. So now the other way to now do this, go to this one. And I think I got these mixed up here, is with a table. So let's see if we get the exact same graph using a table. So now set up a table. And in the middle of our table, notice where we meet. We're meeting at 1. So put 1 in the middle of your table. And then let's pick a number smaller than a couple numbers smaller. And so we'll go 0, -1, -2. And then a couple numbers bigger. So we'll go 2, 3, and then 4. And then this is a review of what we did at the beginning. So if I want f of -2, then doesn't x equals a -2 satisfy this first inequality, that it's less than or equal to a 1? So I want to take a -2, I'm going to plug it into this first one. So I would do 2 times a -2 minus a 1. And we would get a value of -5. All right, so plot that point, -2, -5. If I take a -1, think about where we fit. -1 satisfies, again, this interval here. So take your -1 and plug that in. 2 times a -1 minus a 1 would be a -3. So go to -1, -3, plot that point. The x value of 0, if we again look at our interval here, 0 satisfies this first inequality still. So I'm still going to do 2 times 0 minus 1, which is going to be a -1. Plot that point, 0, -1. Then we get to the 1, and the 1 is the important point because that's where these meet. So if we look at this one, notice how the equal sign at 1 exists in this first one. So we still need to plug 1 into that first equation and do 2 times 1 minus a 1, which is just 2 minus a 1, so 1, 1. So you're going to plot that point. If we now connect those, doesn't that give us the same look that we had in that previous graph? The reason I'm now connecting those, if we go any further, if I go to 2, doesn't 2 now force us to use that second equation? Because 2 now starts to satisfy the second one. So let me do this one in red so it looks like the one that we did above. So take your 2, now we're plugging it into this one. So I would do a -2 plus 3, which is 1. Right, let me screw that up, so 1, 1. All right, so plot that point, 2, 1. And then plot 3, so -3 plus 3. Again, I'm just plugging it into the second part. I'm going to get a 0. So then we get 3, 0. And then the last one, if I take my 4, 4 satisfies that second one. I get a -4 plus 3, which is a -1. So 4, -1. And then we would continue this one here. That's how you can do it with a table, but it takes to me, it takes a lot more work. But if we look at these two guys, they should look very, very similar, right? From here to the one that we have up here. All right, any questions on that? This is our next one I think I want you to do today. Yeah, this is our last one, good. All right, so now what I want you to do, go backwards of what we just did. We're gonna write a piecewise function for this. So the way we're gonna write this, put f of x. Notice how we have two different pieces, 1, 2. So we're gonna put a big brace. And we're going to put equation number 1 here. And we're gonna put equation number 2 here. So we have two different parts to this. All you're going to do, and this is something we should be able to do, write the equation of this line. So just y equals mx plus b for this line right here. So the one that I have highlighted, write the equation of that line. So I'll put it over here. Tell me what the slope of that line is, what the y-intercept of that line is. All right, that's something we should be able to do. Just worry about the yellow one only. We did a bunch of these yesterday. All right. Do we agree? If I look at the line that I have highlighted in yellow, our y-intercept is right here. So the b should have been a -1. All right, we all got that, hopefully. So I'm going to erase this b. I know my y-intercept is a -1. We then need to count our slope. So I'm going to use this point. Here's a good point. We have a lot of good points to pick and count in between. So I'm going to go up 1, left 2. Up 1, left 2, up 1, left 2. If I continue to go up 1 and left 2, I continue to land on that line. So up 1 is a +1, left 2 is a -2. So that then means my slope is a -1/2. Since I have called this line number 1, that means we come over here and write that equation in the first line over here. Then I'm going to have you do the same exact thing for the second one. Now write the equation for this line. A little trickier. Let's see if you can be clever and figure out what the slope and y-intercept of that line would be. All right, let's see if we were clever. Let's actually get the slope first, right? Because the y-intercept should be what's tricky about this one. So let's do our slope. Here's a point. Here's a point. A lot of points here. Pretty straightforward. I'm just going up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So up 1, right 1 is just a +1 over a 1. So the slope of this line should be a 1. Now, don't say that that doesn't have a y-intercept. If that line continued on, wouldn't it eventually cross the y-axis if it was going the whole way? So let's now go backwards. So instead of going up 1, right 1, up 1, right 1, which takes us away from the x-axis, let's go down 1, left 1. That would be the first point. If I go down 1, left 1 again, if I extended this line, wouldn't I have crossed the y-axis at a -1? So we're going to say our y-intercept, if that line were to continue, we're going to change this to be a -1. That's the second equation, 1x minus a 1. So all we did is wrote the equations of those two lines. Something you've been doing a very long time now is just writing the equations of lines. But what we now need to do is, for each of these, put a little comma, a little comma. We want to define the interval where these are defined. So look where line 1 is at, where it stops. Look where line 2 starts. Doesn't that switch at 2? So doesn't line 1 exist for any x value that's less than 2? And then if I look at line 2, doesn't line 2 exist for 3, 4, 5, 6, all the x values that are greater than 2? And then notice where the solid dot is at. Isn't the solid dot in the second one? So that's the one that we want to use our equal sign for. All right, that's this piecewise function for this graph right here. All right, makes some sense, hopefully. A little bit. All right. And now, no homework. You have a second page of all of this. We're going to review these tomorrow. And then I'll probably give you a little something to practice and try. But we'll just do some more of these tomorrow. So no homework on this. hopefully after you get out of here tomorrow, it'll make a little more sense. You'll be able to go through these a little bit. Now it's the second day of seeing it. Okay. All right. So with that, we're good. All right. Have a good night. Bell's going to ring anyway. If we were, oh, hello, Cam's family. How are you? Is that your sister, Cam? Hello. Learning some algebra. I like that. Yeah. Teach them young. Teach them young. All right. No, no. All right. We'll see you guys. Have a good day. Bye.